Hello YouTube viewers, welcome to my channel S2T. In today's show, Future Friday, we're gonna talk about electric aircraft. So let's dive right into it. Well, first, what we are talking about? We are talking about electric aircraft. We are talking about specifically a small class aircraft. We are not talking about something jumbo jet size, something small. Now, the whole point of this puppy is that it has to be 100% all electric. Same way our petrol engines went from petrol to hybrid to all electric, there is also a category of hybrid system in aviation industry also. But we are not talking about that. We are talking about all electric. Now, generally, as of now, so far, lithium is the only candidate. There are other chemistries that could make some amazing revolutions. So far, lithium is the only prime candidate. So we are talking about lithium-based small aircraft that is 100% electrically powered. So let's dive right into it. Now, how does this puppy work? Well, it generally starts with a very high power electric motor. Now, you have to understand this one aspect that there are motors and there are many types of motors. Some of them are very efficient, primary of which would be induction motor. But here's the deal. You must have noticed is that even if you have a corded drill or a vacuum pump, generally they do not use induction motor. Why? Well, they use universal motor. Why? Because it's cheaper. Okay, you might say, what about something expensive? Again, they will still use it. Why? It's small. It's very powerful for its size. Basically, if you give 1 kilogram, how much Newton meter you can get out of it is much higher compared to an induction motor. But it does not last long. It's like, it has brushless, it's very inefficient and noisy as hell. So there is always a trade-off. So whenever you are talking about motor, you cannot just like, okay, I'm gonna put a three-phase motor into this. You can do that with any electric car, and three-phase induction motors are powerful enough. However, even in that scenario, when Tesla wanted more extra oomph out of it, they put magnets into their stator, which is generally not done normally, but they had to do that for getting extra power. Hall back array they had to create. So here the same problem is because it's an aircraft, because it's ultra light, saving every kilogram matters. So the motor designs here are not run of the mill induction motor, run of the mill BLDC motors. They are ludicrously specifically built so they have maximum power to weight ratio. So it's not as simple as that. Now, consequence of that, their motor drivers are also complicated, and not to mention they also have to do regeneration. I mean, like, how the heck aeroplane is gonna do regeneration? Basically, when you are approaching and you have to like apply air brakes, it will turn the basically propeller into a quote unquote windmill, and it will start rotating. Now, benefit of that, your plane will lose speed very quickly, very efficiently, and you're gonna recharge like around 1 to 2 kilowatts of energy can be recharged from doing this. So it's a tangible enough thing to do that it's worth doing it. So you have to understand that motor driver have to be designed in such a way that it can handle that kind of oomph. And you're talking about 20-30 kilowatts per second. So this is a very big drain on normal systems. So your electronics must be able to handle it constantly. Like that kind of load happens on a car motor also, but they have to handle that as in spike. Oh, like push the pedal to the metal, that spike. That spike is not here. It's like continuously on that what we call duty cycle. So it's built completely differently. Now, this is one interesting part about that. They can utilize modular battery. Modular battery is flat out impractical in road vehicles. Why? Because road vehicles are designed to handle crash. Basically, they're gonna crash, people should survive it. So they have to make sure the chassis is completely intact. They act as a monoblock. Basically, it's one thing and we know how it's gonna behave. That cannot be done if you have giant things coming in or out of it. And that is why even in E1, basically Formula One's cousin with electric cars, they also do not have like battery swapping. They're simply like just go into different vehicle. It's much more easier for safety reason. Here it's a plane. If it crashes, you did it, so it does not matter that much. So all they have to make sure is safe enough, like as in like the bolts that you are using, they're not gonna randomly fall apart, and the batteries will not gonna fall out and all that jazz. Again, those things are there, but it's not like, oh, you cannot do this, you have to have a rigid chassis and all that jazz. That's not there. So they use modular battery in this. Now, what about the range and speed aspect of it? Now, single-seater aircraft will give you the maximum range. As of now, you can buy 500-kilometer range kind of electric aircrafts. 500 kilometer is a very long distance. Now, you might be like, if you are using Google to measure distance, you might find like, even going from one place to another, it might be like, 300 kilometers and all that. But if you draw a straight line from point A to point B, from airport to airport, it's not that much. So 500 kilometer may sound very small if you're used to Google Maps, but if you are seeing like, direct point to point, 500 kilometers is very far. It's like very far you can go. And the biggest consumer of basically electric aircraft, trainer aircrafts, they can right now do around 200 kilometers easily. Like you can just go and buy and you can easily do 200 kilometers easily. And what about commercial? Now if you are familiar with electric aircraft and you have that in your YouTube feeds, you must have seen these aircraft. Now this is a Canada-based system using a seaplane, and they are upgrading the seaplane from basically fuel-based to electric-based. Now this puppy is a very big deal simply because this is the first commercial system. It's not a training aircraft, it's not a racer aircraft, it's not single use, it's commercial. Basically they're gonna put 6 people into it and ferry them from point A to point B. Well, that's a very big deal. However, the consequences, their range is much smaller. They can only do 100 kilometers. So now you might be like, plane 100 kilometers, that does not sound too much. There are many scenarios where 100 kilometers is more than enough. Even like they, before investing millions of dollars into it, of course, they did research. So in their research, like there were a lot of people who want to do short hops from point A to point B. And again, this is a seaplane. It's built for that kind of thing. So their mathematics was like, dude, if we can do 80 kilometers, we good, we golden, we can cover most or to almost majority of our consumer demand. So they did it, they built it. Like 100 kilometers is enough for them. Like from one basically whenever you're talking about crossing rivers, canals or channels, those sort of scenarios, those are not very wide. Like but again, you have to go through either by a ferry, which is much slower, or you have to go by train, which is much tedious for, and assuming you have a train as an option available. Generally train would be the best, but it's not available everywhere. So this puppy is a very good competitor in those sort of scenarios, those exact use cases. Now what about the speed aspect? Now again, to give you a context of speed, we generally have aviation like big daddy aviation from jumbo jets. Those are generally below supersonic, aka they will not cross Mach 1, they will be below Mach 1. Now you cannot be at around Mach 1 simply because the drag would be ludicrously high because your shock plates are not stable yet. So generally would be 700 kilometers per hour to higher than that, like as high as they can go without wasting too much fuel. So 700 maximum fuel mileage, 800, 900 if you have very high altitude, but you're not going to push 1000. So that's the general range for like 700 minimum. But when you're talking about something small, something like a single propeller kind of aircraft, they're not going very fast. They're barely doing like 300 to 400. This puppy can start as 150 to 250. Now you might be like, that's low. Yes, absolutely, it's low, but it's more than good enough. 250 kilometers per hour. Most of you do not drive that fast. Even if your speedometer is in miles per hour, you're not going to drive at 250 kilometers per hour. And for single seaters, there are some companies that are building racing specific. Those can hit as high as 500. So yes, they can go fast, but again, for practical reason, even like when you're talking commercial sea hopping plane from point A to point B, the speed is enough. Now, how the heck you gonna charge it? That's a big deal. Now, in reality, charging anything is not an issue simply because barring few exact things, most things have a lot of idle time. Like for your car, what is your car doing right now? There is a very good chance, unless you are inside your car is in some park spot or in a garage, it's not doing anything. Like only taxis do, and even taxis do not have duty cycle of 100% time. Like they are not on 100% of the time. Most of the time they are just chilling. So, and aircrafts are much worse than that. So most of the time aircraft, especially small ones, not jumbo jets. Jumbo jets are being utilized like there is no tomorrow because they can swap out crews. But small aircraft, they will be like most of the time, like once a week it's being flown. So charging them is not an issue. But even with that, like what about training aircraft, which has to be flown regularly? They come up with a swappable battery. That is the another reason for swappable. So you're just gonna swap the batteries, and swapping can be done in few minutes, or you can charge the system, and because the batteries are used much more lighter and they have much better cooling system, they can be charged in 1 hour. Generally they can give you 1 hour flight time in 1 hour charging time. So but it's not an issue. Like it's really not an issue in the aircraft industry. So what about the economics of it? There are many designs of it, many hopes, dreams, ideas and all that. But if economic does not support it, you dead. So what happens here? Now here's a kind of interesting, it's completely invert of it. Basically electric cars versus petrol system. Petrol is cheaper to start and even cheaper to maintain because electric cars have ludicrously high, like what you call a bulk capital cost. But here it's kind of invert. The electric planes are not too expensive, and even the replacement batteries are not too ludicrously expensive, but petrols are. Why? Simply because it's an aviation grade industry. Every component has redundancy. Like you do not have one spark plug, you always have two spark plugs, and you're not going to have normal cheapo spark plug. You're going to have the best of the damn reliable system. Everything, every aspect. And on top of that, maintenance in a car is something that you can delay. Maintenance in aeroplane is not something that you can push off. Like if it says get your stuff checked at 1000 kilometers, or every 2000 kilometer you have to do that. In electric, no such thing. So practical people who are actually using it in 2019, flat of them, data collection from a lot of sources will give you the same answer. It's 80% cheaper per mile per hour. Basically, if you are flying for 2 hours, if you are using hour as a measurement, you'll still find it's 80% cheaper. If you're per mile or per kilometer, still 80% cheaper. That's a lot of money saving. And maintenance aspect is very serious in aircraft industry learned this the hard way, so to say, by losing hundreds of people due to poor maintenance is not taken like everything, from every dipstick to every spark plug maintenance, everything is thoroughly tested. In electric, inherently you have such fewer components, you don't have to say, and most of them will scream at you through computer screens that, bro, this is broken. So maintenance cost goes down. Now they are very quiet. Now quiet aspect is very difficult to understand, is simply because if you are inside the plane is as noisy as ever. Now you're like, why the hell that is? Simply because you are getting hit by the propeller air itself directly, like it's 1 foot ahead of you. Of course it's gonna sound like crazy, but when you're talking about from ground, let's say you are here and plane flies by, it has the same effect as electric car. Basically, unless it goes through you, you're not gonna hear it. Now that's a very good advantage, simply because many training institutes, they want to train pilots for nighttime flying, because things happen. Heck, eclipse can happen randomly. You're flying and random eclipse happens. Like, you have to know how to fly in the dark, or have to have that training where they teach you to rely completely on the instrument rather than on your eyes. You need to do that in nighttime for maximum effectiveness. But if you are in small town, you're not gonna fly a noisy plane during nighttime. People is gonna complain and your school would be shut down. Has happened. So making a quiet plane, awesome. It actually allows many schools to do what we call nighttime operations. Now, if you're talking about short hops from point A to point B, I'm not talking like hundreds of kilometers going from China to Shanghai or basically Hong Kong to basically Sweden. None of that. Like normal small hops from let's say large airport to small your regional airport. This is well suitable. Like, it's God sent for those kind of scenario. However, when you're talking about long flights, like, yeah, I'm gonna take off from 24-hour long flight. Yeah, don't even think about it. Flat out, nope. So this is the core aspect of it. Whenever you are talking about electric aircraft, yes, even companies like Airbus and Boeing, all of them are working into hybrid system right now to reduce their fuel consumption. It's something that is being worked on right now. However, in terms of electric, don't even think about it. Flat out, electricity cannot touch this. So there is no way a jumbo jet can be built, simply because 1000 kilometer is that quote unquote Goldilocks zone. You cannot exceed that. 1000 kilometer with current technology. Again, if you have magical technology, it's a different thought. But so far 1000 kilometers is so quote unquote absolute. It's like you cannot cross this. Now, passenger capacity is also an issue, because 1000 kilometers, there are many flights that are below that. But if you talk about passenger quality, then it's like, nope. Passenger quality is like 2 passenger, 4 passenger, 6 passenger. We have to reach a point where it's like 20-25 people. And whenever you are talking about, like, the most successful system right now in aviation is twin turbofan engine space systems, because they have a carrying capacity of 100 to 200, and they can go from like literally cross continent. So they are amazing. They are the backbone right now. These big giants are no longer used as much as they used to be, but this puppy is very powerful. Can electric aircraft come even close to this? Nope. Not at all. Core physical reason is low energy density, aka how many megajoules you have in your battery per liter per kilogram. It's so low that it's laughable. It's like 40 times less. So flat out, it's not comparable. Do not even think about these things. Hybrid, maybe. Electric, nope. But what can you do? Like, if a core backbone of aviation cannot be touched, what about everything else? Well, it makes amazing trainer aircraft right now. Flat out, people are falling over themselves to book those things. So that's amazing. Then you have to understand that short hops is not an industry that does not exist. Same with a seaplane company, there is like a whole market of these which are underserved, simply because aviation has this kind of weird relationship. Is that, like, the shorter your flight distance, the more expensive it becomes. The further you go, the more efficient it becomes. So small basically regional airlines, they suffer like crazy because of this. Heck, even in India, like Indigos are like have to shut down a lot of regional systems, simply because the price fuel costs have to go up. Same happened with Air France. Same happened with many airlines went under, simply because short hops flights are very, very expensive. So inherently, if you can do short house flight based on electric system, amazing. Like complete like lower maintenance, and maintenance is a thing that is very difficult. Like it's a big chunk of your airline's investment. Like it's a big chunk. Now, what happens if we can reach mid hops? Now, mid hops is around 500 kilometers. Now, this can change the world. Like if we reach 500 kilometers, that's so far that most Airbus A380 was built on a logic what we call spokes and hub model. So basically, you're gonna have like two giant airports from point A to point B, and then from China to USA, and then from those main hubs, you're gonna have multiple small flights. But small flights are not practically feasible in terms of cost system. But electric can do that. So if that happens, mind blowing. Like it will have amazing effects on the aircraft industry. So if basically mild hops, basically 500 kilometers, like you can go from point A to point B in 500-kilometer jumps without any issue, that will change the world. That will flat out change aviation. Now, because regional flights are suffering the most, like there are many places where you have like one small air strip to another small air strip. It's just there is no way to run a flights between them. Like it used to be the case, like there were many planes doing this, but as fuel prices went up, as maintenance became much more stringent, much more regulations and all that jazz happened, they died out. So that can be revitalized once again if electric planes reach that golden mark of 500-kilometer range. So can it happen? Absolutely, it will happen. It's just how long? 2022, you will be talking about like 100-kilometer range. 2030, you will be talking about 500-kilometer. Because technology is there. Like if you want to build it right now, you can build it. It's just that aviation regulation will take that long to justify it. So this was my presentation on electric aircrafts. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me an extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.